Institute of Model Physics, Institute of High Energy Physics, and Hefei Institute of Physical Sciences, and USTC, and so on. It is well known that the energy is a serious problem for us. For the mainly now we use the fossil energy, in the last century, nuclear energy give a way to partly solve the problem, and this is one of the greatest invention in the 20th century, and this revolutionary change in the concept of energy. I think you know about that. And in the future, nuclear energy is also one of the major energy source we must learn on. And nowadays, the increment of the use of nuclear energy increase rapidly. For this, this is the data for 2010, and maybe in the next 10 years, China will build another or several, maybe more than 10 nuclear power plants, and the total power can reach up about this, and this is the percentage of the nuclear power in the total electrical power. Under this condition, we must face two main problems. One is the fuel, and another is the safety. For the fuel, you will know that the CNEP have tried to solve this problem. And another is the waste. At the beginning, someone suggests one through to treatment the nuclear waste. But now, mainly we think of the closed cycle of the use of the nuclear fuel. And the main important issue of this is the long-lived radioactive toxicity, such as the long-lived fission fragments, products, and minor actinides. I show you here only one example for nuclear power station of 1 gigawatt electric, and the fuel may be used 25 tons per year, and the spent fuel also about this, and the reusable about this, and plutonium, and some short-lived and mid-lived fission products about 1 ton, and the minor actinide about 20 kilograms, and the long-lived fission products about 30 kilograms. And for China, it have 2020, the nuclear power it can generate about 70 gigawatt, and the spent fuel can reach up to about 7 million tons to 12 million tons. So the problem we must visit the cement field. And a lot of research showed that ADS may be a hopeful role to provide a breakthrough to make the nuclear energy a safe, economically efficient, and acceptable and environmental friendly energy source. The principle of the ADS is use high energy intense particle beam to bombard heavy element and to produce high flux of high energy neutrons, and then induce nuclear reaction, and then transmute the MA and LFP. And for the constitution of ADS is the combination of accelerator, stabilization target, and subprotocol. So from the research results we have got, now we think ADS is to be considered as the best solution for nuclear waste transmutation. And this is a nuclear waste transmutation cycle. This is for the reprocessing and the waste to the MA and FP, and separation and to the fabrication of the fuel element to the ADS, and after the during the working of the ADS, the heat can generate electricity. Part can supply the machine work, and another for the user. For the transmission cycle, if no treatment by the one through, the lifetime of the radioactive element or isotopes can at about more than million years. And after close circling recycling of the cement field, radioactive toxicity decrease. And if we use ADS plus the closed cycle, the toxicity decrease more, and to some one can predict and to protect the disaster of the from the cement field. In the past more than 20 years, in the world, many groups have studied the ADS, and some projects have proposed by different countries, such as the ThEC12 from the USA, and the multiple hybrid research reactor for high-tech applications, MIRA from Belgium, and some from Japan, Korea, and Italy, France, also from Belgium, and from Russia, and so on. The target of the project mainly there are two parts. One is solid, another is liquid metal, mainly for lead bismuth, and tungsten, and so on. This is some parameters of this project. And this is the field used in the plan used in the project. But now no large full-scale project realized, because it is real a challenge for the, not only for the scientists, also for the, I think, for the user of plants. These are the two problems, and the solution is for this is use the sodium, and this for use ADS. And the Chinese Academy of Sciences started one new project. The name is a Strategy Priority Research Program of this. And we, both of these two parts belong to the Advanced Nuclear Fusion Energy for Future for this project. And the roadmap of ADS of Chinese Academy of Sciences is divided 4 phases. The first one from 2011 to 2015, mainly for the ThEC technique R&D, for the accelerator target and the reactor prototype. And for the phase 2, the gather of this the component to one to build a research facility. And for this, for phase 3, it's an experimental facility. And for the fourth phase is a demo facility. This is the roadmap of use for the ECR source, RFQ, some superconducting spore cavity, suppose the LINAC, and this is the reactor. The technical options of this project for the accelerator, mainly for superconducting proton LINAC, consists from ECR source, RFQ, as he spoke. The energy to about 1 GeV to 1.5 GeV, and the current is about 10 milliamp. For the solution target, 2 selections. One is the lead bismuth acetic, and another is the hybrid target, and also maybe solid target. And for the subcritical, the first choice is the lead bismuth acetic cooled type or the gas cooled type. The goals to 2015 for the accelerator is mainly supported by the Institute of High Energy Physics and the Institute of Modern Physics. The constructing 25 to 50 MeV with superconducting proton LINAC, and determine the technique needed for higher energy up to 1 GeV at 10 milliamp, and also to develop a technical design of superconducting proton LINAC up to this. And for the simulation target, mainly supported by IMP. First is test bench of heavy metal target with window or windowless target, and also technical design of simulating target, and for at least 1 GeV at 10 milliampere per ton beam power. For the reactors, mainly supported by HIPS and USTC. The further is a test bench of liquid lead-bismuth security and 10 megawatt reactor with lead-bismuth or gas cooled. And also we built a new institute for this project. And for the budget, now approved is about 1.8 billion Chinese yuan. This is for the divided to 5 parts for the related researches about this, and for the accelerator R&D, for the simulated target R&D and the reactor R&D, and for the support systems. And also planned about this 1.8 billion Chinese yuan for the phase 2. This is for phase 1, this is for phase 2. And the framework of ADS management is headquartered from the CAS, and then there is an international advisory committee, and also a scientific and technical committee. Then ADS research center. After this, from the supported institutions. For the related researches, mainly from IMP, IATP, HIPS, and USTC. For the accelerators, mainly supported by IMP and IATP. For the target, IMP, and for the reactor, HIPS, and USTC. For the for this supply for IMP, IATP, HIPS, and USTC. Now to show you some progress. Now we have done the preliminary conservative design of the system. This only show you a sketch of it. And for the accelerator, advisory committee suggests the plan have approved by the review committee and the advisory committee. And there are 2 ways to go to the lower energy proton injector. One is supported by MP, ECR source, and RFQ, and ICHWR. And for IHEP, ECR source, RFQ, and spoke cavity. And then for the energy higher than 10 MeV, this is the same. There are 2 ways to get this. This some progress. This is the iron source now is under commission. And this RFQ one have done now on the test. And for the cavity and the nearby cavity also done module and now on the test. This is on the, for test on the liquid helium temperature. And for the development of ADS-oriented code and method, we use not only PC but use a GPU to do this, and develop some code and compared with other commercial code. We can calculate the use this the grid to about 10 to 8, and also do some test to verify the code. For the test, you use water to for the measurement, and also for the nuclear date, because for the neutron date for the neutron energy higher than 200 MeV, it's the lack of the nuclear date. So we use our machine to do experiment. This is the accelerator of MP. The energy of this can reach up to more than GeV. So we can use this to test some nuclear date. And for the measurement, we use a light charged particle from the simulation and the neutron energy spectrum, spatial distribution, multiplicity, measurement of the residues from simulation, proton beam energy scanning, and so on. And this is one of the experiment with the radioactive activation measurement of calibrate the detector and try to get some new data. And for the reactor, also done some preliminary design of this. These are the type, and this is the parameters, and this. And also constructing RB loop for the test of the liquid business, the property of this. This loop will be work in the next year, about April. And there's some other small test loop. Now I show you only a brief summary. ADS to be best solution for nuclear waste transmutation. However, the development of the ADS system is really a big challenge for us. And CAS ADS project was started since 2011, and some progress have been achieved. And more specific investigations, such as high-intensity particle accelerators, the target materials, wind features, and so on, need to be. And also, we now we do some collaboration with others. Now we wish to do more collaboration with the scientists from all over the world. Thank you.
Thank you. Can I ask how your linear accelerator that you proposed compares with the one at the Chinese spallation source?
The power?
The current, the energy, the overall design, is it similar, or is it an upgraded version, or is it something totally different that needs to be reinvented?
In the phase 1, the energy much lower than that. But the final goal is the same energy, but the intensity much higher than that one.
Takaki from Tokyo City University. You mentioned ADS is the best solution for waste transmutation. And totally agree, ADS has very high, it's a very effective tool. In more technical term, ADS has very high transmutation ratio, transmutation rate. But transmuted amount of minor actinides is almost proportional to the thermal output, thermal power of ADS. So in the term of transmutation amount, ADS has not such big number of transmutation amount because the thermal power is limited. So I'm a little bit skeptical. ADS is the best solution, and I'd like to. My question is, did you make a fair comparison between critical system and subcritical system, and what is the logical procedure you choose ADS is the best system?
Good question. For ADS, the spectrum of the neutron spectrum is very hard, so the transmission cross section is larger than other reactors. But for fast reactor, also it can also transmit some actinides. But this for the comparison between the fast reactor and the ADS, the efficiency of ADS is about several times of the fast reactor.
Hi, Mark Halper. I'm a freelance journalist here blogging for the Weinberg Foundation. It was interesting to see that you're opening a new institute. Can you tell us a bit more about that? What's the timeline for that? Where and when? And by the way, where are you now? Are you Shanghai, Beijing?
I'm sorry for that, but because this has not been well decided, I can't say that.
Can't say. Okay, where are you based now? Can you say that? Where are you? Where do you call home now? Are you based in Shanghai or Beijing or?
There are some places as a candidate site, but not decided. Not be decided now.
Thank you very much once again.